So, hello everyone. I'm Marius. I'm a senior software engineer at CrateDB, and I would like to welcome you all to this fifth module of our workshop, where we will talk about query planning in CrateDB and optimizations, so that you can make your queries run faster. So just a few words, as in every module, you can always use the Q&A function of Zoom to post your questions, and we'll try to answer all of them at the end of the module, the Q&A section. And as probably you already know, that the session is recorded, and later on it will be shared with all of you. So in this module, we will first talk about how to understand the query plans for your queries, so that you can then dive in and try to make them as performant as possible. We will talk about some common performance issues for queries, and later on we will show some query optimizations and examples. So first of all, let's talk a bit about query plans. So a logical plan, as in most databases, is the first step that every query translates to. It's an abstraction of your query and the way it will be later on transformed into an execution plan in order to actually be executed in the cluster and return the required results. So we will start with a simple example with just selecting the column name from the table users. And in order to get the logical plan, you just need to prefix any query you have with the explain keyword. So for this example, we can see that the explain plan, the logical plan we get is really simple. It's a collect operator. It's where you collect data from for the table users. You see that the users is prefixed with the default schema name for CrateDB, which is doc. You see that we only collect name, which is the column we ask for, and that the filtering for this query is true. So we ask to return everything as we see we don't have any workloads here. In the next example, it's almost the same query, but we want to return all the columns for users table, and we now filter on the name column, which is a text one. And you can see here it's still a collect on the same table, but here we have a list of all the columns that we return because of the star. And here, instead of true, we have the actual filter that we applied. Let's move on to a little bit more complex query, where we have now also an order by and a limit. So now we see that the logical plan is a bit more complex, and always the way to read logical plans, as almost in every database, is to go from bottom to top, because the bottom one is the one that will be executed first, and above that more and more operators we will apply in order to get back the desired results from the query. So here we still have the collect operator, of course, because we need to get data from table users. We have a query. It's a like operator on the column name. And here we ask for two other columns that may seem a bit weird, but we'll explain right away. So we ask to return from the collect operator to return ID, because we need it afterwards right away by the order by operator to order the results that we get after the filtering. And then we ask for the fetch ID. So this fetch ID is a system column, it's internal, and we use it because we don't want to fetch all the columns available before applying any other operators. In this case, the operator we want to apply is limit. So we don't want to fetch lots of data. Imagine that the table could have 100 columns. We don't want to fetch 100 columns and then apply the limit operator. So instead, what we do is that we ask for a fetch ID, which is uniquely identifies the rows. And after that, after limiting the results to 50 as defined in our query, we use the fetch operator, which uses the fetch ID, and it asks to from the fetch operator to get back the rest of the columns required to return to the user. So if someone wants to dive deeper than the logical plan, and in some cases you need to do so, you need to get back the actual execution plan of a query. And in order to do that, you need to prefix your query with the keywords explain, analyze. So unlike the previous, so the explain that returns the logical plan only, explain, analyze will actually execute the query normally as it would, but instead of returning back results, it will return you the detailed information about the execution. So here is just a short example, but don't worry, we will have more examples later on to understand what's going on here. And also, you can see, we'll explain also later that the filtering that you are using, it actually most of the times will translate into a Lucene query, and here you can see the name of the exact Lucene query that it's used to execute the filtering. So let's move on to something a bit more complex, which is a join. So here we are using two tables and we join them together on the respective columns. So the logical plan that you get from here is, of course, to collect phases, because you need to get data from both tables. And then you have the join operator. In this case, is a nested loop join. After that, there is some extra filtering because of these workflows. And since we have used aliases for the column names, you also have a rename operator that does that. Here you can see almost the same query, but instead of having a greater than join condition, we have an equal. So this is a equi join as called, an inner join with equality operator. And CrateDB would most of the times use a much more performant hasp join operator instead of the nested loop that we saw before. Here you can see a link with a video explaining more about the join algorithms that are implemented in CrateDB. So when it comes to queries and trying to optimize their performance, or having issues and trying to see what's going on there and what's wrong with the system, there are a few things that you should always be careful for. First of all, one must always check the operating system and hardware metrics. So CPU, memory, disk usage, and try to avoid node hotspots. That means that maybe your 10 node cluster performs really well overall, but there are one or two nodes that are really saturated because maybe there is a sharding problem or something else is going on, some issue with the disk or the memory in those nodes. So apart from the system and operating system levels metrics, one must also check the JVM stats, especially the memory usage and the garbage collection performance. So frequent garbage collection can mean that the system doesn't have enough memory to cope with the load, and maybe we should consider to increase the memory, if possible, of course. Another thing that it's important in the cluster is to see that your replicas are always up to speed, because if a node goes down, and as explained earlier in previous session and before me by Karin, when primary shard is lost because the node it lives in goes down, then a replica is upgraded to primary shard. But if at that point the replica is not up to speed, then it's missing 1 hour of updates because of whatever reason in the cluster of slow network or some nodes that are saturated, then you will have a replica which has 1 hour less data than it should have. Next, you should be careful about the situation that you have lots of updates and deletes in your tables, and there is a command optimize for that to make your tables healthy again, but I will talk later on in a bit more detail about that. Next is the analyze of your tables. So CrateDB by default, everyone now gathers statistics for the tables which are used by the planner in order to come up with the best logical plan for your query. So if there are lots of updates and deletes in your tables that dramatically change the statistics, then you might need to consider to also analyze manually more frequent than the 1 hour that it's done anyway by the system. And while checking slow queries, long-running jobs can be identified in those tables that are listed here. There are all those are links to the documentation to see details. I'm just listing there the schemas of those tables. So we have jobs and jobs log, where in jobs you have the queries that are currently running in the system that are active. In the log is right after every query insert whatever statement is executed, it passes from the jobs to the jobs log, so you can see all the details there for the completed ones. Then we have the job metrics, which have way more details about your queries, like min, max, mean, latencies, percentiles, total fail count, and things like that. And you have also the operations and operations log, where you can see statistics in a more fine-grained level than the jobs. So every job might have, for example, 3 collects, 1 join, 3 order buys, whatever. So each one of them is an operation that you can see in the operations log table. So before we go to the optimize command, let me show you an example for those system tables for the job statistics. So here you can see that I have nothing running. It's only the query that I was currently running, which is just this select. And if I do something like A join query, I'm doing it with some virtual tables using some table functions. You can see, um, you can still see here that there is nothing running because everything has already completed. But here you can see in the log table all the jobs that run with the statistics. In the metrics table, you can also see more details about what has run. For example, my query was a join, as I said, based on virtual tables. That's the table function. The generate series you see here. And you see that the hash join operation, and you see the metrics for this query. So if I execute it like a couple of more times, these statistics already changed regarding the percentiles, standard deviation, and so on. So we said about optimize, and you might need to use it to trigger it manually in certain cases. So every table is organized into maybe partitions as an intermediate level, but for sure into shards. And every shard is further split into Lucene segments. So Lucene, every time you do an insert delete update, it does not update data in place where it were, but it creates new blocks, new segments, and with the newly updated data. And later on, there is an automatic mechanism that runs all the time that merges smaller segments into bigger ones and cleans off data that are not used anymore because they have been updated or deleted. And the thing is that sometimes the automatic operation cannot do that fast enough or good enough when you have lots of updates and deletes, and you might need to do that manually to trigger the optimize command manually on a table or specific partition of a table in order to merge the segments, to have more segments and have a better performance. So also one another case that you might need to do that, you need to consider to do the optimize manually if you have major schema changes, especially when you are using those dynamic objects that Karin talked about before, and you have lots of new index columns created in your system, or deleting columns from there or updating. You need to run optimize manually maybe to get the better performance from your table. So next we will talk a bit about common performance issues. The common performance issue for everything, the basis of a query is to have a full table scan instead of using the indices. So in this example, we can see that we're using a write function, a string function that gets the first character from the write and converts it to a character, which is a function that won't use the underlying indices and therefore will perform poorly. Another important thing is that, especially because CrateDB is a SQL database, people that are coming from traditional relational databases might have a way to normalize schemas with foreign keys, concepts, and things like that. So they have their data split into many tables, and this is not ideal for CrateDB. Although CrateDB can perform joins and even with multiple tables, not only two, in a clustering environment, and when these tables become bigger and bigger in terms of number of rows, then you can hit a point that your query will be quite slow to execute. So you need to avoid as much as to have data split into several tables, and in order to get back the required results, that you need to join all of them. Another thing would be to have a bad data distribution, so to have it unbalanced. And that can be to have a bad partitioning scheme. For example, because partitioning mostly is used with concept of timing. If you have chosen to partition your table by day on the timestamp, and then you need to always run queries that aggregate results per week or per month, then you end up hitting 7 or 30 partitions for every query to get the results back. So you need to be careful, apart from all the sharding restrictions, not too many shards on a node, or too big shards or too small shards. Also to think a bit about the queries that you want to execute on this table. So you can choose the partitioning scheme wisely. And as said about the sharding, also even when you don't have partitioning, just the shards of the table, by default, CrateDB uses internal ID that does a perfect balance sharding. So if you choose to use your own custom column for the sharding, you need to be careful to not end up with a few shards that have most of the rows of the table and many other shards that have few rows, or the other way around. So you have basically hotspots. Other performance issues is that, as explained, node failures and using the replica shards to perform a query, it's done transparently. But if there are node failures, you may experience queries that last for a long time, because queries, as I've said, Lucene queries in that level, those collect operators and any other operators might be to re-execute it to a replica shard or to a newly promoted primary shard. So yeah, you need to see if you, for any reason, you have many node failures, or nodes that are going down and coming up regularly in your system. Memory is one of the main things to watch for, both for the operating system available memory, because it's used also for the reading data and caching data from the disk, but also the JVM memory, as said before, and of course the garbage collection. So when you have high memory usage and frequent garbage collections, this eat up resources from the system, and you might experience slow queries. Last is to check in general for resource contention, because maybe again your cluster or even the individual nodes seem to perform quite well without any saturation of CPU and memory, but still you can have lots of concurrent queries that are trying to access the same table, the same shards. And when you have lots of replica shards, this can help you parallelize, but always this comes at a cost, because then you get, if you add more and more replicas, you get slower insert times, and also, of course, you use more space. So let's move to the last section of this module, which is query optimizations, and show some examples. again, continuing from the partitioning and sharding, it's important, as we said, when you have a partition table, to try to exploit that and don't let your query hit all the partitions of the table, but rather try to filter on the partition column to make use of the partitioning scheme and hit just a portion of the whole table. In this example, I'm having something a bit artificial to show, but just for the ease of the example. So we have a simple table with A and B columns, and we have a C column, which is not, we don't provide values for that, but it's always generated given a function. It's just a modulo on A column. So we can see here we get a table of at most 10 partitions because of that. And we have chosen to cluster our table into 5 shards, which means, of course, that if you have all the 10 partitions times 5, you have 50 shards in total. So if you do a query like that, where you filter on the B column, which is neither A or C, you hit all 10 partitions, all 50 shards of it. And I will show in the example how the explain analyze looks in the terminal. But if you filter also on the partition column, then you just hit only one shard and only one partition, so only 5 of those shards. So let me, sorry about that. I need to change a bit the format to make it easier to read. So here I'm issuing the query without using the partition column. And if I scroll up and up and up, I can see the same Lucene query, which is executed against every shard, and this whole list will be all 50 shards of the table. But the moment I add the partitioning column, we can see directly that we will have 1, 2, 3, 4, 5 shards being involved here. Another thing to see is that if instead I use the A column, you can see that here I also have only 5 shards that are getting queried, and this is because Crate is smart enough to understand that the A is the column on which C is based on, so it can understand directly the whole formula of A modulo 10. And even though we query on A column, it can understand the partitioning scheme and choose the correct partition only to query. So next, another thing to consider is that SQL language and queries are different in some cases of what Lucene is capable of. One example of this is the thread value logic for Boolean expressions, which it means that apart from true and false, there is also null value, and there are some weird calculations when you have null and true, null and false, or null or true, null or false, and things like that. And since Lucene cannot handle this correctly, in order to be able to execute them in a compatible way for SQL and handle the three value logic and the null handling, CrateDB uses some built-in functions to do that, but that comes at a cost because it doesn't use Lucene indices anymore. And for a simple example with an array of integers and a query here, we can see that this produces 3 nested queries in order to execute this 3-value logic correctly, and it runs in more than 1.3 seconds. But to overcome this, if the 3-value logic it's not important for us and can only treat false and true, we have implemented a special ignore 3-valued function that wraps any other Boolean operator, and this uses the whole Lucene indexing and its own queries, and it can run in a few milliseconds, as you can see here. So another point to look for queries is when you're using geo related queries on geodata. There are different functions to use to perform your query. So there is a within function, but this is again not using the Lucene indices and queries underneath. And the way you can see that is when you do the explain analyze. You can see that instead of some Lucene query, you always get in such cases a generic function query, which means in order to execute that, it will need to read all the data from the columns involved, of course, from the table in question, and then apply the built-in function on that in order to filter out and proceed to execute the rest of the operations for the query. But when you use the correct geo related functions to do your matching, then you can see that you are actually using the Lucene geo queries underneath, which will be much more performant and will filter out your data without a full table scan. So we talked already a bit about this write operator that you can filter on a string. You can see if you use the explain analyze that this is again a generic function query. Sorry. It's a generic function query, so it's a full table scan and then a built-in function that it's applied on top. But if you use the like operator with the wildcard here to just match the last character of the string, this is again translated to a Lucene query which uses the indices. And I can show you also with an example here, a terminal with the same query. So I'm using a count star here to make sure that I get all the results back. It's the same as having a limit 100, 1000 or so. So if I execute this, which is the write operator, it uses almost like half a second, a bit more. But if I do it with the like operator, you can see that this takes almost half the time. And you can also see it with an explain analyze. Sorry. You can see the types of queries that are executed in each case, as I explained before in the slide. Another thing to consider is mathematical operators and filterings. So these again are two equivalent queries in terms of filtering and what kind of results you will get back. It's exactly the same. But absolute is not a function that it's executed by Lucene. It's again a built-in function, and it's a generic function query executed for Lucene. Again, full table scan, but we can easily rewrite that to this expression. So he greater than 10 or x greater than 10 or x less than minus 10, and this will be translated to a much more performant Lucene query using the indices. So next, let's talk a bit about something which is experimental. It's not in our documentation for the time being, but we are planning to start exposing some things here. With this query from the PG catalog table, you can see all the different optimizer rules that can be applied in your query. So these are all applied transparently to you before you get back an execution logical plan when you use the explain keyword. But if you choose if you have some query that the logical plan is not good enough and you want to affect it a little bit, you might want to switch off some of the rules here to make the optimizer behave differently. Of course, again, this is experimental, so it's not guaranteed that the query will work 100% no matter which of the optimizer rule you switch off. So let's see an example about that. So give me a second. I have a simple table here, which I order by column A descending, and then this is becomes an inner query, a subquery, and it's wrapped by another one, which orders the result by A, but ascending this time. So if you see the logical plan, let me switch back to the other format to see better. If you see here, we have the usual collect phase, and we only have the order by ascending, the outer one, because it doesn't make sense to first order by in the descending order, while the outer query will ask for the ascending order anyway. But if in any case you want to do something or the query planner doesn't behave smart enough in your scenario, you can switch off a rule. In this case, I'm just showing this simple thing to switch off the deduplicate order rule. So after you do that and you execute the query, you can see that this logic, this optimization didn't apply, and you get the two operators, first descending order by and then ascending order by. Also keep in mind that these settings to control the optimizer are only for the session. So the moment that you log out from crash, for example, they are switched back to the default, which is true. Next, I would like to show you an example that comes from real life, from our community, to see how complex queries CrateDB can execute, and actually how fast if you spend some time to optimize them. So initially, we have a query with various aggregations and joins in between and unions and ordering and so on. And originally the query used several seconds in order to execute, but when We rewrote it with the help of our great customer engineers that jumped into this issue with a CTE expression. We got a much better performance, and then by again tuning a bit the where operators that were used for the filterings, we ended up to executing the query to around, I remember, 200 milliseconds. Yeah. So when you have complex queries, there might be a case that the optimizer, the planner and the optimizer are not smart enough to come back with the best logical and therefore execution plan for you. So you might need either to rewrite your query in a bit better way, or maybe tune some stuff with the your filterings, or last resort is maybe do these things with switching off some of the optimizer rules. So just a few words about future world in the planner and optimizer. So there has been some infrastructure work that took place. So we now model our join queries with graphs, and this will be very soon released with the 5.5.0 version. With that, some more optimizations for join queries, especially some cross-join elimination is being included with those changes. We also have some more optimization rules that can be switched off on demand, and this especially have to do with the reordering of the tables when more than 3 or more tables are involved in the join. And for future work, we want to implement the DP hype algorithm for the join ordering. We have an issue here. You can check it out with links to the original paper there. And this is all based on graph modeling. That's why we did this preparation step already for that. Then after that, after this implemented, we want to further benchmark join queries and maybe also tune our cost estimation for such queries. Also for future roadmap, not yet planned, though exactly when, we want to optimize the so-called correlated subqueries. When you have a subquery which refers to some join condition joining actually with an outer one, which can be converted to semi-joins or to something like that, an in-query. There are other ideas for further optimizations about some cases where you can further push down aggregations to be executed before joins when that makes sense, or filter out nulls when you're joining two columns from two tables, of course, and for one table the column doesn't allow nulls, then you can already pre-filter nulls for the other table as well. Or maybe even implement more join algorithms on top of the nested loop and hash join that we already have, maybe the sorted merge join. And that's it. So I think it's time for questions. So let's see.
So Marius?
Yeah.
I see the first question is related to my part of the talk. So if you want, I can address that. and then you can move on to the others because there are many for you waiting
Okay,
for you.
I was going to ask if you want to address it now or at the end, at the last Q&A after this.
Okay. Well, I will address it shortly if you don't mind.
Okay, yeah, of course.
Thank
Go
you.
ahead.
Okay, so hello everyone, this is Karen again. So there's one question here, let me answer. So based on my answer on the full text analyzer, it works only on entire words or defined piece of words tokenizer, but not on parts of words as the function like offers, right? Exactly. So as I explained in the beginning, the match will not go through the records, the rows, the rows that you have there. It will go through the index already defined, so the inverted index with the terms. So depending on how you have them tokenized, you can run some of the match queries there. Otherwise, yeah, it does not work as the like on that sense. Okay. I don't know if you had anything, but that's my answer there. So yeah, go ahead.
Yeah, thank you. So the next question is that is it post update files of the table? Okay. Yeah, I quickly opened this issue. Yeah, it's not possible yet. So you can do some plain update queries, but not if you want to use subqueries there. So.
So Marius, can we just repeat the question because there are a couple of them
yes,
and it's not clear which one you're answering. Thank you.
Yes, sorry, thank you. So the question refers to an issue in our community board, and it says, is it possible to update values of one table with corresponding values of another table joined on an ID? I have tried in CrateDB the same query that works in SQL Server and it failed. Table name of second, table unknown. I have seen this point has opened in 2020 and so on. So yeah, this is unfortunately not possible yet still in at CrateDB. So you can do updates, but only with simple queries. You cannot have complex subqueries that the result is used to update a column. So next question is, does CrateDB query cache results and how does it affect query performance? So CrateDB itself does not cache any results, but it uses the query cache mechanism from Lucene. So there it actually caches Lucene queries with the document IDs that are returned for each one of them, and it's used heavily. So when there are no changes, you might get even faster responses back without needing to go through actually the index and the query, at least for specific segments or sharps, if there are no changes to your data in between. Yeah, just to add that CrateDB, if you use JDBC prepared statements, the only thing that it's cast is that you have already an analyzed statement at your hand, so you don't need to go through the whole parsing and analysis phases. So next question, is it possible to update the values timestamp of a table with the lagged value of another field? I don't understand exactly. Maybe you can add some more. So you want to update the table with the lag. So if I understand correctly, you want to update for one row a column using a value from a column from a previous row. So no, you cannot do that. It's in the same area with the subqueries for updates, and you cannot do that yet. So next question. What are some common types of joins in CrateDB, and how can optimize for better query performance? CrateDB supports all the kinds of joins, the usual kinds like cross join, inner join, left, outer, full outer joins, and the executions that algorithms that we're using are nested loop and hasp join. So hasp join is only used for inner joins with equality, at least one equality operator in the join condition. So if you don't have this, everything else is executed with nested loop. And in terms of query performance, everything has to do with how big is the table and how many are the tables. So of course, when you have nested loop involved, you might end up with slow performance. But again, if your tables are relatively small because there are some kind of lookup tables, still the nested loop will perform really, really fast because it's also distributed. It's not run only on one node. It all comes to the specific use case. So suggestion of nice to have. Yesterday you explained that the console of CrateDB allows to retrieve previous queries executed. It would be interesting to be able to search by keyword as is possible to Unix. Yeah, that's great. You can always feel free to open issues to the respective repository. It's crate-admin for that. You know that I showed also in the terminal. I think you can still see my screen. So here you can go, of course, back, and you have all the goodies of Unix to search back into queries. So this is our standard client. It's Crash that comes with CrateDB. So if you, I think that admin console is more of a bit of play around in terms of the console query, not for heavily usage in terms of administration or really querying the database. So I normally suggest to use this client, but yeah, again, feel free to open a request for such things to get a better user experience for the console, the admin UI as well. Thank you. I think that was the last question. Thank you.
Yeah, I also think that was the last question. A lot of very interesting questions today. So before we finish, I would first like to thank Marius and Karin for excellent presentations and a lot of interesting content. And I would like to invite all of you to try out CrateDB Cloud. What is really interesting about our CrateDB Cloud offering is that you can deploy one cluster for free without actually leaving any payment information. This cluster has certain characteristics, but it's excellent playground to start working with CrateDB. Of course, there is also open source version, and we would just like to ask you to try it out and let us your feedback. So I know there were a lot of questions, but there is also option if you want to talk to us more. You can use the links on this page, and I think these links have been shared with you in the chat, to contact our engineers or to actually join one of our office hours sessions that we host once per month, and the next one is going to be actually next Wednesday at 5 p.m. Central European time. And during these office hours, we are there to essentially answer your questions and to, like listen to your use case, give you some good practices, and actually learn more about how you use CrateDB. Thank you a lot for being with us today. And we hope you enjoyed 2 sessions today and yesterday. And we really hope to see you next time. Thanks again for being with us.